Welcome back to Learn As You Explore, your go-to place for mBot2 tutorials. If you're a passionate teacher, check out the Educator packs I've put together, linked in the description. You also have a free lesson pack to check out before you make a purchase. Let's do a quick recap of our previous video now. We started off with our previous pick and place part 4 project. We then refactored the ball tracking and gripper close part, which is the pick operation. Then we added a loop within which we can add the logic for landing area tracking as well as the gripper open part, which is the place operation. Finally, we added support to actually perform landing area tracking, followed by playing the audio tone and then opening the gripper. In today's video, we'll update the two functions track and explore to make them handle both ball tracking and landing area tracking, do some cleanup, and finally upload and test the project on the robot. Let's get started. Now let's think about what would change within the track function. So let's go there. So depending on whether we're tracking the ball or the landing area, what do you think will change here within the track function? If we look at our main program, when we use or call the track function, we call the track function in two cases. In the first case, we're calling it to track the ball, and in the second case, we're calling it to track the landing area. When we want to perform ball tracking, we call the track function using ball X and ball Y. These will replace the track X and track Y input arguments to the track function. Similarly, when we want to track the landing area, we call the track function using landing X and landing Y for the input variables track X and track Y. So nothing really needs to change in the if part of this function. So as long as our track function uses track X and track Y within the calculation for wheel powers, it will be able to handle tracking any X and Y coordinate that we provide as input into this function. So nothing really needs to change within the if block here. Now let's look at our explore function, because that is called in the else part here. The explore function currently gets ball X and ball Y coordinates directly from the smart camera, but what if we wanted to add exploration for the landing area as well? Then we need to let the explore function know when it needs to track the ball and when it needs to track the landing area. To provide this information to the explore block, let's add a color block input number to the explore function. So add an input number and we'll call it color block. Say OK. Now we'll make two new variables. We'll call them tracker X and tracker Y. Notice that these variables are named differently compared to the track X and track Y input arguments to the track function. Replace ball X and ball Y with tracker X and tracker Y instead. Change ball Y to tracker Y. We'll also replace the places where we've used ball X and ball Y with tracker X and tracker Y respectively. So drag on tracker X here and finally drag on tracker Y here. Now what we want to do is, if the provided color block is 1, then we want to use color block 1 to set tracker X and tracker Y, and if it is 2, then we want to use color block 2 to set tracker X and tracker Y. We can easily achieve this by using a couple if blocks, so let's bring that over. We want to check here if color block is 1, so let's go to operators, grab an equals block, and then drag the color block variable and set it to 1 for the condition. We can drag this if block within our forever loop. Now we don't want to do all of these things when color block is 1. All we want to do is set tracker X and tracker Y, so we can move this if part outside the if check. Similarly, we'll add another if block to check for color block 2. Make sure to insert it right after the first if block for color block 1. Move the if block again outside And here we can duplicate this block and insert it here. We can also duplicate the condition and insert it in the second if statement. Set the color block to 2 here in the condition. Tracker X and tracker Y need to be set to the X and Y coordinates respectively, but of color block 2 instead of color block 1. Great, now that we have this, let's see how we're using the explore function so that we can provide this input color block to it. We use the explore function only once in our program, which is within the track function. However, the track function itself currently does not know what color block it is tracking. So let's add a color block input variable to the track function. Go to edit and add an input number and call this color block again. Say OK, and now we can pass this colored block into our explore function. Now we have to go back and see where the track function is used because we just added an input variable to it, and make sure that we're passing the correct value for color block in every place that we're calling track. So track is used within our main program once to track the ball and once to track the landing area. We know that for the ball, the signature number or color block number is 1, so we'll leave this as is. We also know that we set the landing area as color block 2 in Pixelmon in our last video. And that is it, guys. You've done an awesome job following along and programming this rather complex but powerful program where the robot is super smart in how it approaches the pick and place project. It will first explore to find the ball. Once it finds the ball, it switches to all directions ball tracking, gets really close to it so that the gripper can hold it, closes the gripper performing the pick operation, and then it moves on to exploring to find the target area or the landing area, and it avoids obstacles at the same time. While it does that exploration, it gets to the landing area and then drops the ball, performing the place operation. So you've implemented exploration, obstacle avoidance, and pick and place all in one project. So I really applaud you for following along so far and implementing this amazing program. Let's go and test it out on our robot now. Make sure your robot is powered on and connected to your computer. Click on connect, select the COM port and say connect. Click on upload code and wait for the program to be uploaded. Once uploaded, you can now go and test it out on your robot and see the program in action. Hey guys, I just wanted to tell you about one more change that would be nice to do before testing it on the robot. In our explore function, when we encounter an obstacle, we usually turn left 45 degrees, but I'd like to change this to something like 20 degrees so that the robot doesn't miss out detecting the target just because it turned too much when encountering an obstacle. You can play around with this number to see what works well in your setup, but for me 20 degrees worked well, so I'm going to go with that. I'm going to save the program again, connect the robot, and upload code once again. And now I promise that we're going to go and test it out on our robot. I'll see you there. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.